In section 3.9, we are going to review everything that we have learned in chapter 3 about graphing lines. We start off on page 71 in the packet with a summary of the different formulas we have been using. First, it reminds us how to find slope by comparing the vertical change to the horizontal change. And the important thing to remember there is that we want to be sure to put the y values on the top and the x values on the bottom. Then we have the formula for the slope-intercept form of an equation, y equals mx plus b, where m is the slope and b is the y-intercept. If we write that as an ordered pair, which we should do, the 0 will come first and then the value of the intercept. Then we have the point slope form. We use this if we know the slope represented by m and any point that is on the line. The difference between the point slope form and the slope intercept form is that the slope intercept form requires a very special point, the y-intercept. And we don't always know that. In the point slope form, we only need one point on the line, and it can be any point, not a special point. So it is more flexible. Once we have point slope form, we can rewrite it into slope intercept form. Then we also have standard form of a linear equation, ax plus by equals c. And in that form, we can find the x-intercept by setting y equal to 0, or find the y-intercept by setting x equal to 0. We have two special cases, a horizontal line and in a horizontal line, it will be a very short equation, y equals whatever that constant value of y is. For instance, y equals 3. And then we have a vertical line. Again, that will be a very short equation, x equals whatever that constant x value is, for instance, -2. All right, so we're going to try to use all of these things together in this section. We start off with group work 1. It asks us to write the equation of the line below by identifying the slope, the y-intercept, and writing the equation in slope-intercept form. Now, I encourage you to stop the video as we're going through this, try it yourself, and then press play and see if you have correctly answered. There is no new information in this section, but it can definitely challenge our brains to put all the information together in one section. And it's good to challenge your own brain to do that, secure those neural pathways we've been building, and then press play and see if it matches what I have done. All right, so for this first one, to figure out the slope, I'm going to choose 2 points that are on exact crosshatches. For instance, that point right there and that point right there. They are crossing exactly on the underlying graph. Sometimes there's more than one or more than 2, and any 2 will do. Once you have found 2 places that cross exactly on the underlying crosshatch, we want to compare the rise to the run. So in this case, it's going up 1, 2, 3, 4 spots, and then going backwards 3 spots. So my slope will be 4 over -3, which I should rewrite as -4/3 because the denominator can't be a negative in the simplified form. The y-intercept is the point 0, 2. That's where the equation crosses. So my equation is going to be y equals -4/3 x plus 2. Moving in the other direction, they give us the equation in figure 2, and we are supposed to graph the line using the slope and the y-intercept. I'm first going to identify the slope as 4, the number next to the x, and the y-intercept as the ordered pair 0, -3. Be sure to write that as an actual ordered pair, not just the -3. And we already know the equation, y equals 4x minus 3. So I'm going to begin at the value of b, the y-intercept, -3. And then my slope tells me to go up 4 over 1. And I can do that a few times, up 4 over 1, so that I get a better sense of, it'll make it easier for me to draw my line. When I go to draw my line, I should grab my ruler. It doesn't have to be a ruler, but some type of straight edge. Could be a credit card, could be a bus pass, could be the edge of a book, but always use a ruler when you're drawing those lines, particularly on the quizzes, problem sets, and midterms and finals, so that you get an accurate line. Okay, moving on to group work 2, I'm going to find the slope of the line between each pair of points. This will be the same procedure for each point. I'm going to compare the two, for each pair, I'm going to compare the two y values to the two x values. I like to write the second point below the first and maybe clarify for myself which is x and which is y. It does not matter which point I start with so long as I am consistent. So I generally try to make the top value positive, and if I'm lucky, they'll both be positive. So I'm going to start with the 4 minus 1, those are the two y values. And then I have to start with the 3 because I started with the 4, so 3 minus 5. And I get 3 over -2. I should rewrite that as -3/2. I cannot keep that negative in the denominator in a simplified form. They're equivalent, but only the final form I wrote is actually simplified. Moving on to letter B. Again, I'm going to write the second ordered pair below. That just helps to keep track of the x's and the y's. And I'll start with the first ordered pair this time, -1 minus -2. If I started with -1, then I need to start with its partner, 2. 2 minus 7. And I get -1 plus 2 over 2 minus 7, which is 1 over -5. And again, I need to rewrite that as -1/5 so that it is in simplified form. Lots of positives and negatives to keep track of here. It can be easy to get turned around. It's really great practice for our addition and subtraction of integer values. Moving on to letter C, I rewrote -5/2 underneath there, and now I am going to subtract the two y values, and that's kind of strange because they're the same, and then subtract the two x values. So 2 minus 2, starting with the top point, and then 8 minus -5. I get 0 over 8 plus 5, which is 0 over 13. Doesn't really matter what that denominator is. My slope is going to be 0. And I can just double check if I think about what this one looks like. If I just estimate the ordered pair 8, 2 and -5, 2, I see that I am graphing a horizontal line. So that kind of confirms that my slope should be 0. And then in the last one, we have our second special case. I am going to do 1 minus -7. I like to keep those double negatives together so it will become positive. And then 2 minus 2. So 1 plus 7 over 0 or 8 over 0. We cannot take something and divide it into 0 groups, so that value is undefined. 0 under the line is undefined. And again, if I wanted to double check, I could graph those 2 points just to make sure I'm thinking about it right. The point 2, -7 and the 0.21, and I will find that I have indeed been given a vertical line, and the slope of a vertical line is undefined. Alrighty. Moving on to page 73, group work 3. I am now being asked to write the equation 2x plus 4y equals -8 in slope-intercept form, and then state the slope and the y-intercept. So this is similar to what we practiced at the end of chapter 2, where we're solving an equation for a different variable. When we want to change it into slope-intercept form, that is another way of saying that is we need to solve for y. So the first thing I'm going to do is to subtract 2x from both sides. And just like that section 2.5, it feels kind of funny because I can't combine the -2x and the 8. I'm putting the x first because I know I'm going to slope-intercept form and I need to have that x value first. And then my second step is to divide each part by 4. The 4s will cancel out on the left side, and I've got some division to deal with on the right side. So y equals 2/4 is the same thing as 1/2, and it's negative. And then 8 divided by 4 is 2. So my slope-intercept form is y equals -1/2 x. Oh, and look, it should be a -2. I rewrote this incorrectly. When I was doing -8 minus 2x, I lost my negative. So I should have y equals -1/2 x minus 2. All right, for letter B, I am writing the equation of a line passing through the 0.27, and I have a slope of -4. That tells me, even though it's asking for slope-intercept form, I first need to use point slope form because I don't know the intercept. So I'm just writing out that equation so I can plug in more easily. And I'm going to replace the m value with -4. And then I'm going to replace the x sub 0, y sub 0 with the ordered pair. Notice that the minus and the plus are part of the formula. The values I'm substituting are 2 and 7. Once I have done that, I need to distribute the -4 through the parentheses, being careful about my signs. It'll be +8. And then combine those like terms, and I have magically changed the equation from point slope form into slope-intercept form. And if you want, you can perform a check. If I've done all my computation right, I should be able to show that the 0.727 works. So I'm going to put the 7 in for the y and the 2 in for the x. -8 plus 15 is indeed 7. So that just checks that I have kept track of my signs and done things correctly. All right, now I'm going to write the equation of a line passing through the points -2, 6 and 4, -12. And I don't have the slope yet, but I know that I can figure out the slope because I have 2 points. So my first step is going to be to determine that slope. 6 minus -12 over -2 minus 4. That's 6 plus 12 over -6, or 18 over -6. 18 divided by -6 is -3. Now I'm going to go back over to my equation. I'm writing the part that I'm not going to substitute for first. I'll substitute in that slope, and then I can pick either ordered pair. I'm going to pick the first because I actually like that it starts with a negative value. That's going to make it positive inside the parentheses. And then I will go ahead and simplify. -3 times x plus 2 plus 6. Y equals -3x minus 6 plus 6. Kind of an interesting one because those cancel out. So the y-intercept for this line is 0. And again, I can check this if I want, just to make sure. I'm feeling a little uneasy maybe because I've got that strange y-intercept of 0. If I put in either point, it should work. So I could put in 6 and -2. -3 times -2 is 6. That works. And I can try the other one as well. -12 is supposed to be equal to -3 times 4. Also works. So I can perform a check with the points I have to make sure I haven't made a calculation mistake. All right. Letter D, what is the slope of the line x equals 7? And this is to try to review our special cases. The way I like to think of that x equals 7 is if I split apart the x, it's shaped like a V, so that tells me it's a vertical line. And a vertical line has an undefined slope. You cannot walk on it. It's like falling off of a cliff. And then conversely, what's the slope of a horizontal line? And remember, if you want to think about being able to kind of turn that y over, it kind of looks like the letter H. That's just a trick to help remember it. A horizontal line has a slope of 0, a very effortless walk, a flat piece of ground. All right, and then there's some questions about parallel, perpendicular, and neither. We've got the line y equals 5x and the line y equals -5x. In order to be parallel, they'd have to have the same slope. In order to be perpendicular, we have to be able to multiply those two slopes together and get -1, which does not work. So they are neither parallel nor perpendicular. And then in the last one, the slope of the first line is -3. The slope of the second line is 1/3. This time, if I multiply those two values together, -3 times 1/3, those 3's cancel out, they divide out to be 1, equals -1. That means the slopes are perpendicular. The other way to think about that is these two values are both opposites and reciprocals. They're going in the inverse direction in two ways, and that makes them perfectly perpendicular. They'll intersect at a right angle of 90 degrees. All right, on to page 74. This one is just an overview of sort of some generalizations that we can make about lines that will help us to estimate when we're graphing and make sure that we help us to catch mistakes. If we have a line with a positive slope, when we graph it, we should see that it is moving in an upward direction as we move from left to right. If we have a line with a slope of 0, we should see that it is a perfectly flat line. A line with a negative slope is going to be moving down as we move from left to right. The same way that we read a number line or read English is the direction we're thinking about with that negative. So I know there's an arrow on both ends, but this line is pointing in a downward direction as time progresses. And then an undefined slope is going to be straight up and down, vertical. If two lines have the same exact slope, they are parallel. They are tilting in the same direction. If two lines are perpendicular, the product of their slope will be -1. Another way to think about that is they will be both opposites and reciprocals, perfect inverses of each other. I hope that you found that to be a good review. We'll be using this in our next section, 4.1, and I look forward to putting our knowledge of graphing lines to work solving problems.